How Earth got its water and atmosphere long before oceans sparkled under sunlight or winds whispered through trees. Earth was a violent, molten world scorched by impacts, shrouded in toxic gases, and seemingly inhospitable to life. Yet today, our planet teems with water and breathes with an atmosphere perfectly tuned for biology. How did this transformation happen? The story of Earth's water and air is one of cosmic delivery, volcanic fury, and biological revolution. A tale written across billions of years. The fiery beginning, a dry, airless world about 4.6 billion years ago. Earth formed from the solar nebula, a swirling disk of gas and dust orbiting the newborn sun. As planetesimals collided and merged, gravity pulled them into a growing sphere. But this early Earth was far from habitable. The energy from constant impacts and radioactive decay kept the surface molten. Any water or light gases present during formation were quickly boiled away by the intense heat. The initial atmosphere was likely just a thin veil of hydrogen, and helium quickly stripped away by the solar wind. Earth began its existence as a dry, barren rock without oceans, without breathable air, and without the chemistry that would one day support life. The delivery of water, comets, asteroids, then late heavy bombardment. If Earth was born dry, where did all the water come from? Scientists now believe that most of Earth's water arrived after. The planet formed delivered by celestial travelers from the outer solar system. Comets, often called dirty snowballs, are rich in ice. Originating in the Kuiper Belt and Oort cloud, they contain frozen water, carbon dioxide, methane, and organic compounds. When their orbits brought them inward, many collided with young Earth. But comets alone may not tell the whole story. Studies of isotopic ratios, particularly the deuterium to hydrogen, DH, levels in Earth's oceans suggest that asteroids played a major role. Specifically, carbonaceous chondrites, a type of water-rich meteorite from the asteroid belt, have water with DH ratios nearly identical to Earth's oceans. Between 4.1 and 3.8 billion years ago, the solar system underwent a period known as the Late Heavy Bombardment. Gravitational shifts among the giant planets destabilized countless asteroids and comets, sending them on collision courses with the inner planets. During this cosmic storm, Earth was bombarded by millions of impactors. Each strike released steam from vaporized ice. Over millions of years, this relentless rainfall condensed into rivers, lakes, and eventually, vast oceans. Imagine, a single large asteroid could deliver more water than the entire volume of the Mediterranean Sea. Multiply that by thousands, and you begin to see how a parched planet became blue. The birth of the atmosphere. From poisonous gases to breathable air, Earth's first true atmosphere didn't come from space, it came from within. As the planet cooled and a solid crust formed, volcanoes erupted across the surface. These eruptions spewed massive amounts of gases trapped in the mantle, mainly water vapor, carbon dioxide, CO, nitrogen, and sulfur dioxide, and small amounts of methane, shane, and ammonia. This process, called outgassing, built the second atmosphere thick, hot, and dominated by CO. Sound familiar? It's much like today's atmosphere on Venus or Mars. There was no oxygen, no ozone, no protection from solar radiation. And yet, this dense, greenhouse-heavy air played a crucial role. It trapped heat, preventing Earth from freezing, despite the fainter young sun. Then, something extraordinary happened. Liquid water began to condense. Rain fell for centuries, oceans formed. And with water came change. Carbon dioxide started dissolving into the oceans, forming carbonic acid. This led to chemical weathering of rocks, which locked away CO in carbonate minerals like limestone. Over hundreds of millions of years, Earth's CO levels dropped, dramatically cooling the climate and making room for new possibilities. The Great Oxidation Event. Life remakes the sky. About 3.5 billion years ago, simple microbial life emerged, likely near hydrothermal vents or in shallow pools. Among them were cyanobacteria, tiny photosynthetic organisms capable of a revolutionary act. using sunlight to split water and release oxygen as waste. For hundreds of millions of years, oxygen reacted with iron and other elements in the oceans and rocks. Vast banded iron formations were laid down silent records of a changing world. Then, around 2.4 billion years ago, the sinks filled. Oxygen began accumulating in the atmosphere. This was the Great Oxidation Event, one of the most dramatic environmental transformations in Earth's history. Oxygen was toxic to many early anaerobic life forms, causing a mass extinction. But it also paved the way for aerobic respiration, a far more efficient way to extract energy. Complex life became possible. Over time, oxygen built the ozone layer OV, shielding the surface from deadly UV radiation and allowing life to colonize land. Think about it. Every breath you take, every lungful of oxygen, is a legacy of ancient bacteria that changed the sky. The atmosphere we know today. Today, Earth's atmosphere is 78% nitrogen, 21% oxygen, and 1% argon, with trace amounts of CO, water vapor, and other gases. This balance is not accidental. It is the result of geological, chemical, and biological processes working in concert over billions of years. Nitrogen, mostly inert, accumulates because it doesn't easily react or dissolve. Oxygen remains high thanks to ongoing photosynthesis. Carbon dioxide is carefully regulated by the carbon cycle linking the atmosphere, oceans, biosphere, and geosphere. In short, Earth's air is not just a blanket of gas. It is a dynamic living system, an invisible ocean that sustains every creature on land and sea. Conclusion: a planet-transformed Earth did not start with water or air. It earned them. Water arrived on icy comets and rocky asteroids, forged in the cold outer reaches of the solar system. The atmosphere bubbled up from volcanic depths, then was reshaped by rain, rocks, and ultimately, life itself. Without these processes, the bombardment, the outgassing, the rise of photosynthesis, we would not exist. So the next time you drink a glass of water or take a deep breath of fresh air, remember, you are consuming the remnants of ancient stars, shattered worlds, and invisible microbes that dared to change the sky. You are not separate from nature. You are made of its deepest histories. 2024 Cosmic Origins Project, inspired by Carl Sagan, James Lovelock, and the story of us all.